So let's look at this example problem where we have got ethanol water solution in form of a stagnant film in contact at one surface with an organic solvent in which ethanol is soluble and water is insoluble, hence NB is equals to 0. At point 1 the concentration of ethanol is 16.88% and the solution density rho 1 is 972.8 kgs per m cubed. At point 2 the concentration of ethanol is 6.88% and density point 2 is equals to 988 which is kgs per m squared. So the diffusivity of ethanol is 0.740 times 10 to the power minus 9 meters squared per second. Calculate the steady state flux NA. So let's first determine the given data. So given data there is our temperature 293 kelvins. Our DAB as given is 0.740 times 10 to the power 9 meters squared per second. Then our density, 0.2 there is 988.1. Then density 0.1 there is 972 kgs per m squared. Then molecular mass MA 46.05 and molecular mass MB 18.02. Then Z2 is at 0.02 and Z1 is 0.0. Right. So for a weight percent of 6.8, the mole fraction of ethanol at 0.2 is as follows. So we need to calculate the weight fractions because our equation is giving us more fractions there. So for us to get the weight fraction is that we just divide the weight by our MA of our mass. So it's indicated in that equation there. So we are saying that at 0.2 we are told that the weight percent is 6.8. So we just take the 6.8 there divided by 46.02. Remember mole fraction. Remember mole fraction. XA is equal to a number of moles A divided by total moles. So you'd find that this value is giving us moles of A. Then you would find that this is moles A plus moles B is indicated there. Remember, why are we saying moles? Because the mass over the molecular mass gives us the moles. Right. So after determining our XA2 there, then we can also find our XB2. Remember, XA2 plus XB2. So XA2 plus XB2 is equals to 1. So remember, more fractions adds up to 1. So we can easily determine our XB2. Then applying the same concept for for point 1, where the weight percent is 16.8, we get our XA1 is 0.07323, and our XB is equal to 0.9268. Then one would want to understand, why are we calculating XB2, XB1? Remember, we need to calculate our log mean, XB log mean. So let's now go on and calculate the molecular weight M2 at 0.2. So assuming that we've got 100 kgs, then our M2 is going to be 100 kgs divided by the number of moles that we determined earlier on. There is 0.1477 plus 5.172 to give us M2 there is 18.75 kgs. You will find that this is closer to the molecular mass of our water, because there is more of the water in there. Then calculating molecular weight there at 0.2. So this is supposed to be 1 there. That's supposed to be 1 at 0.2 there. Then that's our value we get there is 20.07. So our CA average is indicated there, is calculated as rho 1 over M1 plus rho 2 over M2 over 2 is the average total mass, total concentration. Then to calculate our XB1, we can use the linear concept, since this is very dilute. There is 0.249, but we can also make use of the equation that makes use of XB log mean. Then finally, all the values are now known. It's now a matter of us just substituting as indicated there and getting our value as 8.99 times 10 to the power minus 7 kg moles per second. Thank you.